Good morning, everybody. This is Kashyap Saharana, your host for today's conference. I warmly welcome all of you to the second day of 4th International Conference on Life and Chemical Sciences, organized by IM Group of Researchers. Today, we go onward on a journey of collaboration and knowledge sharing, bringing together young and passionate researchers from around the globe. Our platform, after 1 year of dedication, has hosted 3 international conferences, 6 webinars. Now we are driving into book chapters and 19 review articles, with 98 authors reflecting our commitment to excellence. And we contributed to social causes like Flood Relief Fund and Palestine Relief Fund. I would like to express my gratitude to the remarkable individuals who have played pivotal roles in our success. Dr. Fahmida Javeen, the Executive Director of and Patron-in-Chief from Bahauddin Zakriya University, Multan, and Dr. Adnan, our Director from University of Swat, who have been actively involved. I extend my deepest appreciation to the Honorable Professor Dr. Memuna Ghafoor Shahid, who serves as patron and co-patron, as well as our esteemed team members Azazul Islam, Mushtaq Ahmad, Miss Faiza, Dr. Sadia Bano, Miss Aksa Iqbal, Safia Khan, Dr. Sara Junaid, Maham Iqbal, Miss Riaj Iqbal, Atir Naim, and myself as well. Together, we lead this dynamic organization with unwavering dedication. Currently, I am doing PhD in chemistry from East China University of Science and Technology, Shanghai. So, as a doctoral researcher myself, I'm excited to be a part of this vibrant conference. I'm very grateful to all of you for joining us today. We will be shortly starting our conference, so if anyone from your friends is missing, please inform them to join quickly as we are all set for the virtual stage for our dynamic and inspiring conference. So let's start with our session with a few verses of Holy Quran. So I would request Mr. Idris Ahmed to please join for the recitation.
I am audible, him?
Yes, you are audible.
Oh, okay. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. اقرأ باسم ربك الذي خلق. خلق الإنسان من علق. اقرأ وربك الأكرم الذي علم بالقلم. علم الإنسان ما لم يعلم. In the name of Allah, the most gracious, the most merciful. Read with the name of your Lord who created everything. He created man from a clot of blood. Read, and your Lord is the most gracious, who imparted knowledge by means of the pen. He taught man what he did not know. Sadaqallahul Azim.
Jazakallah Idris. Now we will play national anthem.
Friends, now it is privilege to introduce our esteemed guest, the respected Professor Dr. Muhammad Nasimullah Qureshi, an accomplished organic chemist with an outstanding PhD from University of Leuensburg, Austria, and a distinguished postdoctorate from Xinjiang Technical Institute of Physics and Chemistry, Chinese Academy of Science. Currently serving as the professor and chairman of the Department of Chemistry at the University of Swabi, Professor Qureshi's contributions to the field are unparalleled. With over 60 research articles, more than 130 book chapters, and a notable impact on industrial practices, his work has earned him international recognition and prestigious awards, including the OEAD Distinguished Researcher Fellowship in Austria. Please join me in extending a warm welcome to Professor Dr. Muhammad Nasimullah Qureshi as he shares his invaluable insights with us today.
Thank you for my introduction. And just I would like to confirm that whether you can hear me
Yes, sir, we can hear you.
and can you see my slides or not?
No, sir, it's not
Actually,
visible right now.
okay, just so I'm clicking the share like that, and then the entire screen is coming to me, but I'm not able to share it.
I would request the Fazanusin please guide Dr. Muhammad Nasimullah Qureshi.
Yes, sir. Can you please click the share button and then
Uh,
click the share screen button, and then you will
exactly,
good to go
I
like that,
I did like
like
that,
I'm
but
sharing. Maybe you just retry.
at the right top of my laptop there is a share screen button like that, and
Yes,
I'm
yes,
just sharing, and then
yes,
the small window is coming. It says screen share
for
content like the
window.
screen window like that tab,
Yes,
and then
yes.
I'm
Yeah,
clicking
just
that one as
yes, sir.
well, and then it comes share your screen like your entire screen, and I'm doing that, but
Yes.
the share the at the bottom there is a screen share is cancel, but it is not active.
Uh, mm, no problem, sir. You can share your slides with us, and we can share it for you.
Okay, I'm just sharing it.
Yes.
I'm just sharing it on the WhatsApp. Is it possible?
Yes, sir. Yes.
With Azaz, I'm doing that.
Yeah. Okay, sir. No problem.
Okay, okay, I'm doing it. You got? You got these slides?
Yes, sir. It's loading currently. We'll share in a minute.
Okay. I think I can do my own as well, if not possible over there. Yeah, I got it. Yeah, okay. Okay, can you do it in the, yeah, okay.
Yes,
Thanks
sir.
for the
Now we can
introduction.
see you.
Okay, okay. Can you hear me?
Yes, sir, you are
Yes.
audible.
Okay, okay. So thank you for the introduction, and I'm Professor Dr. Muhammad Nasimullah Qureshi from the Department of Chemistry, University of Swabi, Khyber Pakhtunkhwa, Pakistan. And today I'm delivering the lecture on the profiling of the Matricaria chamomilla flowers metabolites using chromatographic and spectroscopic methods. The next, please. Okay, so these are the outlines of my study or the presentation of the today presentation. So these are the metabolite profile of the Matricaria chamomilla. And within these profile, the research work which is done over there is the flavonoid analysis, carbohydrate analysis, and the amino acid analysis. And within the flavonoid analysis, there are total polyphenolic compounds determination using the UV visible spectrophotometer. And then the qualitative analysis and with the HPLC PDA methods, and also I use the HPLC PDA MS, and for the quantification I use the HPLC connected with the photodiode array detector. Within the carbohydrate analysis, I did the qualitative analysis using the thin layer chromatograph, which is a very simple technique, and also I use the advanced technique, that is matrix female D MS, which is a conversion or a type of MALDI of MS. And I also did the quantification using the GCMS, and within the amino acid analysis, I did the qualitative analysis using the non-hydrogen test, simple test like that, and also the TLC. And also I use the, like in the carbohydrate analysis, that is the matrix female DMS. And also I did the quantification using the amino acid analyzer. The next, please. Next slide, please. Okay, so this is the introduction of the plant under study, and I use basically the Matricaria chamomilla flower. Basically, what is the reason, and or why it is needed to perform these quality control analysis of the plants, or of other things like the raw material which is used in the pharmaceutical or pharmaceutical medicine, or like the herbal medicine as well. So basically, for phytopharmaceutical industries requires quality control of raw material as well as finished product in order to fulfill the legal guidelines, and also to achieve the satisfaction of the consumer and to get the position in the global market. Basically, this is a big challenge for the phytopharmaceutical chemists, and especially the people or the chemists or the pharmacists who are working with the plants or herbal based medicine. So they have to fulfill the legal guidelines, as well as they have to achieve the consumer satisfaction, and also they have to get the position in the global market. So this is the need, I mean to say, this is the reason why do we perform these quality control analysis, and why do we know, or why should we know the metabolites within the plant to be used as finished product, or within the plant to be used as raw material for the preparation of finished product. So met the plant which is now I'm presenting the plant under study. This is basically a Matricaria chamomilla. It belongs to the family Asteraceae. Is an annual herb native to Europe and Western Asia, and is commonly known as chamomile plant. The plant has been used in a variety of ways, such as in the cosmetics, teas, air freshener, dyes, etc. Next, please. Next slide, please. Yes, so this the photo is in front of you on the slide. It has been used for medicinal purposes since long for various activities like soothing, calming, sedative, relaxation, anti-inflammatory, tenseness, itching muscles, indigestion, acidity, hay fever, asthma, morning sickness, eczema, and sore nipples and exhaustion. So these are different activities which the metric chamomilla has the potential to perform, and these have been used for these type of activities. So one of the study of this presentation or of this research is the flavonoid analysis. Within the flavonoid analysis, we perform the total polyphenolic compounds determination, and before quantification of the total polyphenolics, we perform the basic flavonoid screening, that which flavonoids are there or which flavonoids can be identified in the Metricaria chamomilla flowers extract. So these are the basic flavonoid screening tests like the Wilson-Taubach, Shanoda, Pu, sodium borohydride, and zirconium citric acid tests were performed in order to confirm or to confirm as well as to identify that which flavonoids are present in the Metricaria chamomilla flower extracts. So these tests showed that flavonols and flavones are present in the plant extract. Further, we have to confirm that which flavonols and which flavones are there. So we have to confirm qualitatively as well as quantitatively. And also we perform the quantification of the polyphenolic compounds. So this quantification is done by the very famous method, that is the Folin-Cycalto method. And we use for this purpose, we use UV visible spectrophotometer. And within this experiments, we performed two types of extraction, that is two methods of extraction are compared with one another. One is the microwave assisted extraction, and the other one is the reflux extraction, which is the normal extraction, which is under heating, under reflux heating, extract under reflux. So we use different solvents like the water. We used the ethanol, different combination of water and ethanol, different combination of methanol and ethanol, and also other solvents are used. And the results, which is in front of you on the slide, these are the basically the optimized. So within the microwave assisted extraction, the water extract gave best result, and within the reflux extraction, the 50% ethanol gave the good results. So when we compared the microwave assisted extraction in water, so we got 83.22 milligram of gallic acid equivalent per gram of plant. So these are the total polyphenolic compounds which we got in the microwave assisted extraction in water of the Metricaria chamomilla flower. And within the reflux extraction, we got good results with the 50% ethanol. And this experiment we did for 2 hours, while the microwave assisted extraction we did it for just for 3 minutes and 20 seconds. And you can see that. Can you click again? Just click again. Not going to the next slide. And okay, yeah. So you can see the results that is in the case of the reflux extraction. Not going to the, just can you go to the previous slide? Yeah. So you can compare these two results, that the microwave assisted extraction which we performed just for 3 minutes and 20 seconds and the reflux extraction we performed for 2 hours. So the results are quite, I mean to say, the microwave assisted extraction give quite high results than the quantity of the total polyphenolic compounds in case of the reflux extraction, which is 63.44. So we can confirm that the microwave assisted extraction is much more better in terms of lessening decreasing the consumption of time as well as the power as well as the energy, like that things. Next, this slide shows that the somehow yeah. Can you go to the next slide? Yeah, this one. So this is basically the qualitative analysis of the flavonoids. That which flavonoids we in the previous slides we determined the total quantity of the polyphenolic compounds, and this slide shows the qualitative analysis of the flavonoids which is present in the Metricaria chamomilla flowers. So this analysis we performed with the high performance liquid chromatography, which is connected with the photodiode array detector as well as the mass spectrometer. And, and in this case, we use the 50% methanolic extract of the flower, and the chromatographic conditions consisting of water, one of the mobile phase, as well as the B mobile phase is the acetonitrile with 0.05% formic acid. The flow rate we used 0.5 ml per minute, and we used the gradient dilution, and the injection volume was 10 microliter. And the column we used, that is the hypercell C18. We basically performed experiments with different column with different mobile phase, but these mobile phases and as well as this column are and this injection volume, the chromatographic conditions, these are the optimized chromatographic conditions. And we got from this extract that quercetin glucosides, lutein glucosides, and the camphorol glucosides, and the isoremnitine glucosides and epigenate glucosides were confirmed to be present in the Metricaria chamomilla flower extracts. And the confirmation is done basically on the based on the mass, because we use the mass spectrophotometer. So we also use the external method using the photodiode array detector, but also we confirmed it with the mass using the mass spectrophotometer. Can you go to the next slide? Next slide, please. Yep. So in this case, in the previous one, we determined that which flavonoid glycosides are there, and now we were interested to determine the flavonoid A glycans, not in the flavonoid glycoside, but in the flavonoid A glycans, because flavonoid glycosides are also very important, but flavonoid to determine it with using the external standard methods. So using the external standard method, flavonoid glycosides are very expensive, and to provide all the glucosides is really difficult. So that's why we decided to determine the flavonoid A glycans. For this purpose, we performed the acid hydrolysis of the extract, and this acid hydrolysis is performed using the hydrochloric acid, and the procedure is in front of you. And then we, after doing the extraction and hydrolysis simultaneously, we injected 10 microliter of volume of the extract of the hydrolyzed extract in the HPLC, which is connected with the photodiode array detector, and the detection was performed in the wavelength range of 200 to 600 nanometer. Next slide, please. So basically we did a lot of experiments for the optimization of the chromatographic conditions, that is the optimization of the mobile phase, the column, and also some other like the flow rate and things, many things, and pairing reagent. So we optimize different conditions, and the slide which is in front of you is consisting of the optimized condition. So the mobile phase we used, that is the combination of water, methanol, and we used the tetrahydrofuran and also the phosphoric acid, H3PO4. The column temperature we used 50 degrees Celsius, and the column which gave a very good result in terms of the other columns in comparison to other column, that is the hypercell BDS column with dimension of 125 millimeter, and the width is 4 millimeter with particle size of 3 micron. And we did the gradient dilution, and the method which we used for the quantification of the flavonoid A glycans was the external standard method using different standards like the lutein, quercetin, epigenin, isoremnitine, and camphorol. And these standards are basically we selected because already we performed the experiments of conforming and identifying the flavonoid aglycans, so glycosides. So in the flavonoid glycosides, we confirmed that these glycosides are there. So that's why for the external standard method, we confirmed these standards. These are the slide which is in front of you, consisting of the different calibration curve using the different the standards, that is the lutein, quercetin, camphorol, epigenin, and isoramnitine with different concentration, and the R square value and the state line equation or the calibration or regression equation is also there. So we got very good calibration curve with the HPLC PDA instrument. Next slide, please. Next one. So this is the HPLC PDA chromatogram for the quantification of the flavonoids in hydrolyzed plant of Metricaria chamomilla, and these are the chromatographic conditions. So we got very good baseline separation, and that is the lutein, and also very good resolution, especially in terms of the two pairs, for which we did a lot of experiments. That is, we resolved the lutein and quercetin and epigenin and isomethine. It was quite difficult because of having very nearby similar polarity like the lutein quercetin and also the epigenin and isomethine. So we resolved it quite at the baseline. So we got very good baseline resolution using these chromatographic conditions, using the mobile phase consisting of water, methanol, tetrahydrofuran, and phosphoric acid, and with this column, that is the hypercell column. Next slide, please. Next slide. Yep. So these are the results of the quantification of the flavonoids in Metricaria chamomilla flower. So we got good quantity of the epigenin, quercetin, lutein, isoramnitine, and camphorol. And can you click? Can you click again? Just click again. Okay. So we got. Can you go to the previous slide? Previous slide. Previous slide. Previous slide. Yeah. So we got high concentration among the flavonoids. We got high concentration of the epigenin, that is the 71 microgram per ml of the extract, hydrolyzed extract. And then we got high concentration of the quercetin as well. So these are the standard deviation. We also determined the limit of detection as well as the limit of quantification using the HPLC PDA instrument. The next slide, please. Next one. Yeah. So after the flavonoid analysis, we turned our focus to the carbohydrate analysis, and within the carbohydrate analysis, the things which are in front of you in the form of slide, that is the TLC analysis. And within the TLC, we basically we did somehow like that of comparing it with the standard. So we use different standard carbohydrates, and also we use the microwave assisted extract of the plant. For the TLC, we use the pre-coated silica TLC plate, and for the mobile phase which we use for the TLC analysis, that is the butanol acetic acid water, and the spraying reagent we used is the solution of acetonitrile, aniline, diphenylamine, and phosphoric acid. And we got we identified the fructose, glucose, and saccharose, that is the monosaccharide and disaccharides we identified in the Metricaria chamomilla plant extract using the TLC analysis. Can you go to the next slide, please? Yeah, that is also to confirm that whether the results which we got in the case of the thin layer chromatography analysis, whether these are there or not. So we used very advanced technique, that is the matrix free MELD mass spectrometry, that is the TOF MS, Basically, we use basically the instrument of the Marley-Taff MS, and we use Marley-Taff MS is basically used for the high molecular weight compounds, but we use the Marley-Taff MS using the our own synthesized material that is can be seen on the slide on the along with the spectrum of the thing. That is the using this material which we named as 4,4-azodianiline silica bradykinin, which we synthesized our own. So this is we did not use, because for high molecular weight compound the normal matrices are used. We did not use the normal matrices, that is the dihydrobenzoic acid or like the low molecular weight compound, but we use our own synthesized matrix, and we were quite successful using the Marley-Taff MS for the low molecular weight compound, that is the monosaccharide and disaccharides. So we got very good results. And also regarding this experiment using the Metricaria chamomilla flower extracts, so we confirmed that the monosaccharides and disaccharides are present in the plant extract. The saccharides, the carbohydrates, we detected in the using the matrix-free MELD MS in terms of adduct, like the sodium adduct and the potassium adduct, and similar is the case also. We also detected the disaccharides in terms of disaccharides with sodium adduct, sodium ion adduct, and also the potassium ion adduct. So we confirmed the results of the TLC using the matrix-free MS, and we confirmed that the monosaccharides and disaccharides are there in the Metricaria chamomilla flower. So next slide, please. Next slide. Yeah. So these are the experiments for the quantification of the carbohydrates, which we identified in the case of the TLC and the matrix-free MELD MS analysis. So because the carbohydrates, and for this purpose we use the gas chromatography mass spectrometric analysis. So we use the mass spectrometry, and this mass spectrometry is connected with the gas chromatography. So basically carbohydrates are not volatile in nature. In order to volatilize and the gas chromatography need, because this is a prerequisite for the gas chromatography to be, the sample should be in the gaseous form. So in order to do this, so we derivatize the carbohydrates and the derivatization, because we did a number of experiments for optimizing our conditions, our derivatization condition. So we did, and the optimized condition which we performed is the cellulation. So we cellated our carbohydrates with the BSTFA and pyridine. The pyridine was the solvent, and the BSTFA is a derivatizing reagent in a ratio of 2:8. And also we did this derivatization under microwave. So this is the microwave derivatization using the BSTFA and the pyridine solvents. And also we performed the GCMS analysis. Chromatogram, the GCMS chromatogram is there. We use the capillary column of 60 meter long, and the injection temperature was 60 degrees Celsius, and the MS scanning was performed in between the MZ ratio of 40 to 800, and the different carbohydrates, that is the fructose and glucose, which are the monosaccharides, and sucrose, which is the disaccharides. So we got a quite high concentration of the fructose, and the glucose, and the sucrose. Can you click again 3 times? Click. Just click again. Yep, again. So you can see the fructose in the chromatogram as well, and also the sucrose. And in order to, because to have the reproducible results, we use the internal standard glucopyronoside, so that we should minimize the error. of the gas chromatography and the mass spectrometry. So we use the internal standard in case of the standards or external standard as well as in the sample. So with this way, we minimize the errors which is there in the GC and MS. So we did this experiment and we got quite high concentration of the fructose, that is 134 milligram per gram of plant, and then the glucose, this is 68.84 milligram of gram, and also the sucrose are also in good concentration, that is the 41.85. So these results basically they confirmed the results, the qualitative results of the TLC as well as the matrix female D MS. Can you go to the next slide, please? Next slide. Next one. Yeah. Yeah. So we did the amino acid analysis, and within the amino acid analysis, we use the same model of the like that of the carbohydrate analysis. That is using the qualitative analysis with simple to the complex, and then quantification of the amino acid present in the metric area chamomile flowers. So amino acids were qualitatively determined in plant texture with ninhydrin. This is a very simple test because the ninhydrin is reacting with the amino acids, and this is quite simple test. So also the thin layer chromatography was performed, and then we used for the qualitative analysis of the amino acid in plant extract using the matrix female DMS. So within the TLC analysis, we use different standards, and we use the microwave assisted extract of the plant. And the TLC plate which we used was pre-coated with silica, and the mobile phase for the TLC was butanol, acetic acid, and water. And the spraying reagent we used is the 2% in hydrogen dissolved in acetone methanol, and then the plate was dried at 105 degrees Celsius. These are on the slide. There are different amino acids which we used. 22 amino acid we used, and we detected all the amino acids in the plant extract. Some are in low concentration, some are in high concentration. Next slide, please. So these are the amino acids. Amino acids were also the confirmed using the matrix female DMS. Again, I would like to say that amino acids are also low molecular weight compounds in terms of the protein for which we use the MALDIT of MS. So for the amino acid analysis, we use our own synthesized material as we use in the case of the carbohydrates. So in the case of the carbohydrates, we were quite successful, and also in the case of the amino acids, we got very good results. But in the case of the carbohydrates, we detected the carbohydrates in the form of sodium adduct and the potassium adduct. But in the case of the amino acids, we detected the amino acids in three adduct formation. That is the protonated amino acids, and the sodium adduct, and the potassium adduct. So the result, the spectrum, the matrix female DMS spectrum of the plant extract is there on the slide. So we got amino acids. We confirmed the results of the TLC using the matrix female DMS using our own synthesized material, that is a 4-azo dianiline silica bradykinin, which we synthesized our own self. This is silica based material, and we used it for the low molecular, for detecting the low molecular, or for identifying the low molecular weight compounds using the MALDIT of MS. So these were quite good results we got. Can you go to the next slide? Yeah. Can you click again? Yeah, click again. So these are the again. Yeah. So these are the quantification or the quantitative analysis of the amino acids using the automatic amino acid analyzer as per the according to the method described in the European pharmacopoeia. And the extract which we use is the microwave assisted extract of plant extract. pH first the samples to be analyzed for the quantification. We adjusted the pH because this was the condition required for the amino acid analyzer, and we got different amino acids in quite good concentration, and also we determined the limit of quantification of the instrument. Within these amino acids, within the study amino acids, we got highest concentration of the choline, that is 185 milligram per liter of extract, and then the asparagine and also other amino acids in quite good concentration. Can you go to the please to the next slide? So these are my conclusion. Microwave assisted extraction resulted in better yield of total polyphenolic compounds as 83.22 milligram of gallic acid equivalents per gram of plant. Among the flavonoid glycans, epigenin proved to be in the high concentration as 71 microgram per ml of extract. The thin layer chromatography analysis resulted in the identification of the glucose, fructose, sucrose, which were further confirmed by matrix female DMS analysis and GCMS analysis. For the quantification of the carbohydrates, fructose gave highest quantity, that is 134.045 milligram per gram of plant among the identified carbohydrates. The matrix phi MLDMS analysis and the thin layer chromatography analysis and the amino acid analyzer confirmed the presence of the various amino acids in the plant extract of chamomile flower. Choline asparagine yielded highest amounts as 185 and 97 milligram per liter respectively among the tested amino acids. MALDI-TOF MS is a robust, reliable and reproducible technique as the analysis requires short time and easy sample preparation because there was not so much steps in the sample preparation, and also it took very short time, I mean to say within a minute you can do the analysis, you can get the results using the MALDI-TOF MS. The synthesized matrix female material proved to be an efficient energy absorber for the matrix female DMS analysis of the carbohydrates and amino acids in complex samples like that of the plant extracts. Determination of leading compound, because this is a very big challenge to determine the leading compound in the plant extract, is a big challenge for the phytopharmaceutical chemist. However, reliability and accuracy of the results can be increased using different analytical techniques. So combining different analytical techniques from simple to the complex, you can enhance or you can increase the reliability and accuracy of the results, as well as you can enhance the reproducibility and repeatability of the experiments as well. So with this, I would like to end my talk or my presentation. Can you go to the next slide? I'm thankful to my research team, the Higher Education Commission of Pakistan, and the University of Innsbruck, Austria, for providing a number of opportunities for performing such type of experiments. And I'm thankful to all of you for hearing me. And also, I'm very thankful to the organizer of the conference for organizing such type of conferences, and also for inviting me to be interacting with you people. So thanks to all of you. If you have any questions, so I'm here, and if there is no time constraint, so you can ask the question. Thank you.
I am deeply thankful to Professor Dr. Muhammad Nasimullah Qureshi for illuminating our gathering with the profound insights shared in his pre-impactful presentation on flavonoids quantification, carbohydrates analysis, and amino acids analysis. Your contributions left a lasting mark, enriching the essence of our conference, and we extend our sincere appreciation for the dedication and expertise evident in his work, admiring his commitment to advancing the knowledge. With profound respect and admiration, we express our gratitude for the valuable contribution.
Thank you.
Professor Dr. Qureshi, your presence has truly enriched us, and we offer our heartfelt thanks for sharing your wisdom and research with us today.
Thank you.
Now, participants, it's your time to actively join the conversation with thoughtful questions. Let's make this question answer session a valuable opportunity. If anyone have a question, please raise your hand. Yes, Akhtar Bas, continue with your question, please.
Excuse me, sir. In, in case of qualitative analysis of amino acid, we go for non-hydrogen test. Sir, don't we have any alternate ways for testing them?
There are so many more. I mean to say, then Hyrene is a very simple test for the amino acid analysis. That is why, because basically, my aim was to use the very simple test and then the moderate and then going to the matrix female DMS. So just to confirm whether the non-hydrogen test which we normally use, just to confirm whether the amino acid is there because of the color test, because it gave color test like that. So it is very simple basically, and then there are a number of alternative tests are also available. But just I mean because at that time based on the availability of the chemical, so the non-hydrogen was available to me, and it was also very simple test. So I just started with the non-hydrogen test using the TLC, and then going to the very complex instrument, that is the Marley-Taff MS, and using our own synthesized material to confirm whether our own synthesized material as well as this Marley-Taff MS, which is basically we use the Marley-Taff MS for the our own analysis. But regarding I use the methylation as well, and also the cellulation, and also using different cellating reagent, that is the MSTFA, BSTFA, and also combining it with the other reagent as well. What I personally optimize, the optimized results are the results which give me good results using the BSTFA. BSTFA is basically a cellulating reagent. So there are other cellulating reagent also, and other methods are.
I want to invite Dr. Adnan, who is director of IM Group of Researchers and always being a great sport for us, for his conclusive remarks.
Assalamu alaikum, dear valued guests, participants, and esteemed team. Is the fourth International Conference on Life and Chemical Sciences with the theme From Lab to Life, Emerging Trends in Biological and Chemical Sciences come to an end. I want to express my sincere gratitude and pride for the success of this event. On behalf of the organizing committee, I want to thank our guest speakers, participants, and especially the dedicated team that worked hard to make this conference happen. Our goal focused on providing valuable education and raising awareness through research has come to life through the lively discussion and knowledge sharing during these enlightening days. Organized by the IM group of researchers, this conference provided a common ground for the students, researchers, scientists, and professors in life sciences and chemical sciences to share insights, experiences, and the latest advancement in their fields. The objective we set for this conference were not just met but surpassed thanks to active involvement of everyone present. We successfully encouraged collaboration between experts in biological sciences and chemistry, opening doors to innovative solutions for global challenges, discussions on healthcare drug discovery, sustainable practices, and the exploration of chemistry, of nature, and biomolecular sciences have undoubtedly advanced scientific understanding, paving the way for future breakthroughs. I want to express my appreciation for the commitment shown by participants in promoting ethical chemical research, environmental awareness, and safety measures. This conference has not only been a platform for an intellectual exchange, but also a catalyst for building a community of responsible researchers dedicated to making positive impact on society. Uh, Special thanks to our distinguished guest speakers whose expertise enriched the conference, and to every participant who actively contributed to to the discussion. My gratitude also goes to the organizing team whose careful planning and ensured the smooth flow of events. I am confident that the knowledge shared and connection made during this conference will go beyond these walls and make a lasting impact on the laboratories, classrooms, and research institutions represented here. As we part ways, let's carry forward the spirit of collaboration, innovation, and ethical responsibility that defined the fourth International Conference on Life in Chemical Sciences. Thank you all for your unwavering support, and I look forward to future endeavors that continue to push the boundaries of scientific exploration and social impact. Thank you all.